For each of these, we're going to draw the zigzag formula. And like I mentioned in class, we will number these first. So I know I need to do 5 across. So 1, 2, 3, 4, 5. And then off of carbon 3, I have 2 CH3 groups. For this one down here, letter E, I have 1 carbon and 3 CH3 groups coming off of there, and there's an H on there that's not drawn. Here we're writing the molecular formula. This one has 4 carbons there. This is 5, 6. So I have C8. There's 6 CH3 groups, so I'll have 18 hydrogens. In this one, we're looking to see what is structural isomers or constitutional isomers and which are the same. So this one here has, they're all different. None of these are the same. This one has C4H10O. This is C4H10O. So these two are constitutional isomers of each other. These have C4H8O, C4H8O. These are constitutional isomers of each other. And between B and C and E and F, they're unrelated. Okay, each of these are, this is similar to the last problem. This one here has C4H9N, C4H11N, C5H9N. So none of these are related. All right, these are the constitutional isomers. This has 2, 4, 6, 8 hydrogens. This has 3, 6, 7, 8, 9, 10. So these are not constitutional isomers. This has C4H8O, C4H2, there's 2 here, 1, there's 2 here, and 2 here. So 2, 3, 4, 5, 6, 7, 8. Oh, so these ones are constitutional isomers. Alkyl groups here, this has 1, 2. This is an ethyl group. When you have that Y shape and there's 3 carbons, that's 1, 2, 3. This is an isopropyl. The propyl comes from 3 carbons. This has 4 carbons and a turkey claw, so it's a tert-butyl. This one has 3 carbons. In the straight chain, this is a propyl. For the IUPAC here, I'm just going to start with numbering from right to left because I know this will give it the lowest numbering overall. The group here has 2 carbons, so this will be 3 ethyl, nonane. And that's what I'm going to number from right to left. I have these 3 groups here. They're all 1 carbon, so those will be methyls, and they are at 2, 3, 6, and because there's 3, it gets called trimethyl. The long chain has 7 carbons, that makes it heptane. And this one, if I number it either way, my numbering is going to be the same, so you can try that if you want. I have this group here, there's 2 carbons, so this is an ethyl. These are each 1, so these are methyl. And we're going to list it alphabetically first, so the ethyl will get the 4, or becomes first. This is 4-ethyl. And we have 2 methyls at 3 and 5. So dimethyl. And 7 again is heptane. This one we're drawing, so you can start with the parent name. Octane is 1, 2, 3, 4, 5, 6, 7, 8. And I have an ethyl group at 3. And 2, 4, and 5 I have methyl groups, so this is 2. 4 I have 1, and 5 I have 1. So that's what that one will look like. Pentane. I have 5 carbons, and at 3 I have 2 methyl groups. Right here I have 1, 2, 3 carbons. There's a CH2, a CH3 where the 3 is. At the 1 I have 2 CH3 groups, so that's what that one looks like. And on this one I have C and C. On the first carbon I have 3 CH3 groups. The second carbon has 3 CH3 groups as well. Okay, so for each of these, the strategy is to draw what is listed and then see if what's wrong with it. So this is butane. And if I draw methyl at 2, 3, and 3, now I go to try to rename it. And if I look at it, 2, 3, 3 is higher numbering than if you numbered it 1, 2, 3, 4. So this should be 2, 2, 3, trimethyl butane. So this is pentane and 2-ethyl. But if we correct it, now it's 1, 2, 3, 4, 5, 6. So the longest carbon chain is actually 6 carbons long and not 5 as it's originally listed. So instead of 2-ethyl, we have 3-methyl hexane. And then for this one, I have 1, 2, 3 methyl and 4 ethyl. So here again, if we number with the longest carbon chain, with the lowest numbering, we should get 3 ethyl. And we list ethyl first because that comes first alphabetically, and then 4 methyl, which is also why we switched the numbering on here. So both ways the numbering was 3 and 4, but now we have the lowest numbering corresponding to the alphabetical order. All right, IUPACs for these. My cyclic structure is cyclopentane, and then I have this isopropyl group. So this is just isopropyl cyclopentane. Because you only have one group on the ring, we don't have to have a number there, but you can if you want to. All right, in this one, our groups are methyl or an isopropyl. And the numbering either way is 1, 2 or 1, 2. And so now we use the tiebreaker as the alphabetical. Isopropyl is used here for alphabetical purposes. So this is 1 isopropyl. 2-methyl cyclohexane. Okay, so here's another one where we have to find why it's incorrect. So pentane, 4-methyl. We want lowest numbering, so this one should be 2-methyl pentane. This is 2-ethyl, 3-methyl. Our longest parent chain here is wrong. It should be a hexane. So our naming now is 3,4-dimethyl pentane. All right, here's a couple more. So heptane is 7 carbons, 2,2-diethyl. And now if we look for our longest carbon chain, it's now 1, 2, 3. Octane. So I have 3-ethyl, 3-methyl octane. And then for cyclohexane, I have an ethyl at 1, and at 5 there's a methyl. And this one is a problem with, if this is the numbering, oops, here, the numbering should be lowest. So instead of going clockwise, we're going to go counterclockwise. And this will be 1-ethyl, 3-methyl. Cyclohexane. All right, here we're looking for 6 cycloalkanes with the molecular formula of C5H10. And then determine if it has cis or trans isomers. So cycloalkanes are something that's cyclic, so we have a 5-membered ring. That's C5H10. So what we can do now is go to the 4-membered ring with one group. If you have only one substituent, then that cannot be cis or trans. I can also do a 3-membered ring with 2 methyl groups. There's no cis or trans there. But if I do a 3-membered ring with 1 methyl group here and 1 here, this is the cis. And I can have it where this is the trans. And then the last isomer has a 3-membered ring with, instead of 2 methyl groups, I have 1 ethyl group. All right, some more naming. Cyclobutane with 2,4-dimethyl. This should be 1,3-dimethyl. And then cyclohexane, we have 1 propyl, which is 3 carbons, 2 ethyl. And this one will just be an alphabetical thing, so we're going to renumber it. So it becomes 1 ethyl, 2 propyl, cyclohexane. All right, here we have a cyclohexane ring with 1 methyl group and 1 hydroxyl. So we want to show a compound that has, where it doesn't show cis or trans isomerism. So if you had a cyclohexane, we have 1 CH3 group and 1 OH. If they're on the same carbon, they can't show cis or trans isomerism. But if you put them on different carbons, I can have them be cis here. They can be trans, even if I put them on different carbons or in different relationships in the ring. There can be cis trans there, and then you can do it with the 3 All right, so determine if cis or trans is possible for each of these. If so, then draw them. Cyclopropane is 3 carbons, 1 ethyl, 2 ethyl. This one does have cis-trans possible, so you can have it where the ethyls are on the same side going up. Or that. Oops, that's the same as the other one. So both up or one up, one down. Dimethyl cyclohexane, that's 1, 3. So these can both be up. Or one up, one down. All right, balanced equation for combustion. So 2-methylpentane. Oops, it's pentane, not cyclopentane. So I have 6 carbons here. 9, 10, 11, 12, 13, 14 hydrogens. And so when I undergo combustion, it reacts with oxygen, and we get CO2 plus H2O. And when you go to balance the equation, you can start with carbon. So here on the left side, I have 6 carbons. I'll put 6 here, so the carbons are balanced. Next, balance the hydrogen. There's 14 on this side, so I need to have a 7 here. And then I have oxygen left. So on this side, I have 12 oxygens plus 7 is 19. So what you can do here is do 19 over 2. Otherwise, you can just multiply everything times 2. So it would be 2 of this hexane, or 2-methylpentane, plus 19O2. So both of these answers would be correct. All right, haloalkanes, ethane, 2-bromoethane. So I have 2 carbons. There's a Br on 1 and 2. And then for difluoro, I have 2 Cls, 2 Fs. If you didn't want to draw that carbon, you can just leave it like this as well. Either of those is correct. All right, answer the following questions about the unbranched alkanes has 6 carbons. Is it solid, liquid, or gas at room temperature? This one is liquid. Is it dense or more dense than water, or less dense? It's less dense. It is insoluble in water. And it is flammable. Okay, which of these has the higher boiling point? So I'm comparing hexane to octane. Octane has more carbons, so as you add carbons, that increases the boiling point. So this one is higher. And then between butane and 2-methylpropane, this will have the higher boiling point because it is linear and you can stack better. So if you're stacking a whole bunch of those, there's a lot more intermolecular interactions than with this one, which kind of has a ball shape. So if you're trying to stack a bunch of balls, you can't get that many touching each other. There's not as many interactions there.